All right, so let's talk about the bottom half of that worksheet. You know what would help? I plug this in. There we go. Okay. All right. If we want to translate left C units, Monique, just describe what we need to have.
We have to have a sign.
Where?
By the x and the x squared.
Okay, so it needs to be inside. Okay, so in general, if we want to shift to the left, we need to see a plus sign with that number inside of our function. If we want to shift to the right, Austin, what do we describe what we need?
It'd be the same thing, but flip the positive to a negative.
Okay, so inside of our function, you're going to notice that anything inside of our function is going to affect our graph horizontally. Okay, and you've probably struggled with this last year, right? It's backwards from what we want. The plus C inside goes to the left. The minus C inside goes to the right. Okay. I know that feels kind of awkward, but if you think about like setting the inside equal to 0, it gives you the number where you need to be at. Okay. All right. 3 was up. We want to go up C units. Okay. Kinley, describe what we need there.
It would be x squared plus.
Okay. So whatever our function is, we need to add C. Okay. If you did the bottom half in terms of x squared, please go ahead and change it to the function notation that I'm using on the board. It'll help you when we get to some of the problems that we have later. Okay, my intention was for you to use function notation down below so that we can generalize everything. Okay. All right, and then if we need to go down, C units. Okay, Kaya, what do we need there?
You put minus C outside of the parentheses.
Okay, so anything outside, thank you for using that word, outside of our function is going to affect it vertically. All right, so minus C, we're going to vertically shift down. Plus C, we're going to vertically shift up. These were probably the two rules that probably came quickest back to you. All right, the addition and subtraction for moving up and down. Okay. All right, reflections. Okay. If we are going to reflect about the x-axis, okay, Braden, what do we need to do?
I think you put the F or the negative on the outside of the F.
Okay, good. If we are reflecting over the x-axis, our y values are changing, which means we need something on the outside of our function, so we're going to put the negative outside of our function. Okay. Guy, what about the y-axis reflection?
You put it on the inside of the parentheses.
Okay, good. Anything on the inside of our function affects the x-coordinates, all right? And a y-axis reflection would be switching x values. Now, for the parabola that you are working with, if we have a y-axis reflection, does it change? No, because it's an even function. But for a different function, it would, all right? When we have a negative on the inside, it's going to reflect it in that manner. Oh. I really was partial to the number 4 today, apparently. Okay. Mary Kate, what about our vertical stretch and shrink?
Well, I said whole numbers Make it a vertical stretch.
Okay.
And fractions make it shrink.
And where is that number? Is it on the outside or the inside of the function?
Outside.
Okay, good. So a vertical stretch or a vertical stretch or shrink, we're going to have a number multiplied to the outside of our function. Okay. If C is greater than 1, it's going to be a stretch. I know Mary Kate said whole numbers versus fractions. Let's go ahead and specify it to just bigger than 1, less than 1, because we could have a fraction like 3/2, which wouldn't meet that specification. If C is less than 1, we have a shrink. Okay. How do you apply this? If I have a vertical stretch of 2, what do I do? Okay, if you have that x squared, right, and you stretch it vertically by 2, how do you figure out where those y values go? Okay, x values or y values?
The y value.
Okay, so if you want to apply this, we need to multiply your y times the c value, okay? In your parent function, you're going to take any of your y values and multiply them by c. Can you read that? Should I put it somewhere else? Fine? Okay. Trying to like do the least amount of writing for you. Okay. Okay. And then our horizontal stretch and shrink. Okay. Let me do it again.
It's on
Riley, Emma.
Emma.
Okay, Emma. Okay, I had like a moment of panic. Like, I think you're Emma. Okay, Riley, Emma. What do we do for a horizontal stretch or shrink?
If C is greater than 1, it's a shrink.
Okay, so we have the opposite.
Yeah.
What about where is the C located? Is it in the same place?
It's inside the parentheses.
Okay, so when we have something multiplied inside, that is going to be a horizontal stretch or shrink. The rules are backwards. Also, how we apply it is backwards. For these, well, since it's horizontal, we're going to multiply the x. But since it's inside, we have to do everything backwards. We're actually going to multiply by 1 over c. Okay? Those two rules are probably the ones that you're going to have to really concentrate on the most. I think everything else will come back fairly natural to you from last year. We just got to do some practice. But these you'll probably have to think a little bit more about. They're probably the most uncomfortable. Okay, so we'll just have to be sure to practice those. All right. So let's do a couple examples here. Go ahead and write down g of x for me. Okay, you're welcome to do this on the back of your green sheet and just put it into your notebook. Or if you want to turn to your notebook because you're really particular about where you put your notes, do it there. Okay? You want to take your green sheet in?
Yeah, can we just keep this in the folder?
Yeah, you can do whatever you. I'm not going to boss you around with how to take notes, but we're going to do some examples, so figure out where you want to do those. Okay? Okay, so here's where you probably want your pink sheets out for the parent functions. Now, if you come to this problem and you just draw me a U, it's not going to be sufficient. Okay? Now, the whole point of transformations of parent functions is so that we can take a graph and we can do it very quickly. Okay? So these problems, the most amount of work is like writing everything down. All right? So our parent function. Well, I see that we have a square, right? So our parent function would be x squared. Okay? Don't draw it right now, but I'm going to imagine my parent function here in green. Okay? Minimum, you're going to give me that vertex and then the 1, 1 points. Okay? Because if they're stretched, I need to see that they're stretched. Don't draw that, but I'm just imagining that's our parent function. Okay? Now, our transformations. We need to describe them. Well, I have x minus 1 on the inside of our function. We determined that if we're subtracting a number inside, that is a shift in what direction? Right. So we have a shift right, 1. And then we have minus 2 on the outside, which means we have a shift down 2. So what you're going to do is you're going to take whatever parent function from that chart. Okay, we're visualizing this right here, minimum of those 3 points so we get the correct shape. We're going to shift. What I would do is I would take the vertex, right, that 0, 0 coordinate. We're going to shift right 1 and down 2. There's our new vertex. To keep the same shape, those are the other 2 points that we need. And boom, we have our parabola. If it wasn't for me talking that whole time, that would have probably taken you about 60 seconds. Okay, if you didn't have to write down the questions that I was asking you and that kind of thing. Okay, the goal is for this to be quick. All right. The reason that I don't want you to just draw a vertex with a U is because I need to tell if it's the original shape or if it's being stretched or shrunk. So if this were stretched, then these 2 points would be somewhere else, okay? So at very minimum, you need like those 3 little points right there. Same thing for like an absolute value. Those 3 points you would need, but with the straight lines out of it, okay? Does that make sense? Like what I'm expecting as far as your graph to make sure that it's the correct shape, okay? Now, when I ask you to write in terms of f of x, we've determined that f of x is x squared. So basically, what I want is for you to write your transformations in function notation, just like you did on the second half of that green sheet. So since we are right 1 and down 2, I want you to tell me that we have our function notation. So f of x minus 1 gives us the right 1, and then minus 2 on the outside gives us the down 2. So we're just writing function notation. We're forgetting about what function it is. We're just generalizing those transformations in the notation. Okay. Did we talk about calculators in the test?
Yeah, we're not using them.
Okay, we're not going to use calculators on the test. So I let you use your calculators to do some exploratory stuff. My expectation is that you can graph this with the transformations, no calculator. Can you use your calculator to check your work? Sure, but you need to be able to do it with that. Okay. Go ahead and write down this problem for me. Okay, and then look up here for me. I'm going to just draw the parent function so we can imagine it. You can if you want to, but at the very least, just think about it in your head. So bare minimum, I need you to remember that the square root starts at 0, 0. And we have the coordinate 1, 1. And then it's like a shooting star, right? If you want, you can go to 4, 2 as well. But bare minimum, I need these 2 points right here, and then I need to see that shooting star. Okay? Take about 30 seconds, and at your pod, describe the transformations together. Come up with what those transformations are. All right, Riley P. What transformations do we have?
Vertical stretch of 2 and then left 3.
So a vertical stretch by 2, and what'd you say?
Left 3.
And shift left. How do you feel about that? Vertical stretch of 2, because that 2 is on the outside, and then shift left 3. Okay, my suggestion to you, save the shifts for last, okay? Do all of your stretches and reflections and then shift it. Otherwise, things get a little wonky, okay? So if we have a vertical stretch by 2, our y values are getting affected by 2. So in red here, I'm just going to take these coordinates, and we're going to multiply all the y values by 2. So this y value is 0. That's really not interesting. This y value is 1, so it stretches to 2. This y value is 2, so it would stretch to 4. Then we have that shift left 3. So then you would take those coordinates and shift them left 3. Okay, and in blue, that's our final answer. Okay. You can make notes and then erase them, or you can do everything in your head, whatever works best for you. But what I want to see is this right here. Take about 30 seconds, and as a pod, write down domain and range of this new graph. What is the domain and range of G? All right, everyone back together. Andrew, what would our domain be? -3 infinity? Does that -3 have a bracket or parentheses? Okay, good. And our range, Max.
0 to 0.
Good, very good. And then I guess we haven't done our, in terms of f of x. So our h of x function, we keep the 2 on the outside, but then use function notation and put the x plus 3 inside. No, we're not worrying about the specific type of function. We're just doing plain old Jane function notation. Okay. Now, one thing that I do want to warn you about. If I were to ask you to do the transformations of this function right here, okay, this is not a shift left 6. Okay, please make sure that you factor anything out so that you can apply the stretch of 1/2 and then the shift of 3. Okay, so if there's anything to factor out, please make sure you do that. All right. Can't wait to see your graphs tomorrow. Check your answers. You can use your calculator to check your answers if it's an even problem.